Sorry, I'm starting late. Don't be in a rush to put 2 in. Do this in 2 steps. Find the general derivative, then put 2 in, please. That's just good calculus. You can leave it ugly in the velocity case. In terms of your calculator, you could either have it do the second derivative of the original or the first derivative of your velocity, whichever you prefer. It's supposed to be safer to find the second derivative of what's given. But if you have great faith in your derivative, then that's cool with me too. 2t squared log of t plus 1. How you doing? Okay. Do you agree with those 2 results, or give you another minute? Talk to me, people. Do you agree with V of t? V of 2?
Yes.
Okay, cool. By calculator, do you agree with acceleration at 2? 8.8388? Okay. All right. Then, this is kind of laying the groundwork for speed calculation we'll do later. When you show speed is increasing, decreasing, or whether the thing is moving back toward the origin, and all these things, they can start to get complicated, and you get information overload. And anytime in math you get information overload, it's some kind of organizational tool is handy. I like to use a table, for example. So, say you look at this cube function, which I'm going to have you change to 9t, so it's factorable. Change that to 9t, please. For positive time, or time starting at 0, find when the car is moving right and accelerating by making a table of velocity and acceleration signs. So just so we're clear on the question, I want to know what time frame when both of those things are happening together. That's not 2 questions. Find when it's moving right, done. Find when it's accelerating, done. I want to know when both of those are happening. I will also say this. In terms of physics, I think, talking to the VC students, that their impression is acceleration in physics is if there's any kind of acceleration regardless of sign. It's not 0. You with me? In calculus, accelerating means positive acceleration. And if they want negative acceleration, then they'll say, when is it decelerating? So when I ask when is it accelerating, that means when is there positive acceleration. All right. So in order to get all those possible cases of when is the velocity change, when is it positive, when is the acceleration change, when is it positive, let's keep this structured and organized. Let's start with velocity. How do you find velocity? Take the derivative. It's important that you communicate that you not just roll into the velocity function and not label that, hey, I know that velocity is the derivative of position. Then start to give me the derivative, please. That's important. If 3t squared minus 12t plus 9, if I'm not mistaken. Oh, wait. And if I want to know where this is moving right, then perhaps a good place to start would be, when is it not moving at all? Because that might be a start of a point where it's going to move right afterwards. How would you solve that, please? Factor out of 3, leaving with t squared minus 4t plus 3 equals 0. Does that factor? We have the factor. Farmer Jeremy, what's your
3 times t minus 3 times t.
all done. Just like back on the farm. All right. Time 1 and time 3 then is where it's positive velocity. And I can make a sign chart individually on that, but instead I'm going to hold off and make a sign table. So hold off on those. I'll use those in a second. Now let's go to acceleration. Acceleration, give me a label on where it comes from or what you do to find it, please. Velocity is derivative. I could also take second derivative of position is fine. Either one is good. Both is better. 6t minus 12 equals 0. And that would happen at time equal 2. Now in terms of making a table then, interesting points in time that are happening are 1, 2, and 3, starting at time 0. So let's chart the interesting time frames. From 0 to 1, it's behaving in some fashion. And then from time 1 to 2, from time 2 to 3, and then after time 3. So you could say greater than time 3 or 3 to infinity, right? All right, the velocity. At time 1/2, what's the sign of the velocity? I look in factored form is a good place to go. Positive. At time 1.5, what's the sign of the velocity? Negative. At time 2.5, what's the velocity sign? I think it's still negative, yeah? Still negative. And after time 3, what's the sign? Positive. Okay. Acceleration. I think before time 2, it looks like it's negative. And after time 2, its acceleration is positive, right? So now let's answer the question. When is the car moving right and accelerating? Car is moving right and accelerating on what time frame? 3 to infinity. And if they ask for justification, it would be because velocity and acceleration are positive. Wait. Okay. All right. Let's do 2 more types of type, the derivative type, and then we'll move on to the integration type. Okay. Given the height of a ball thrown up at an initial velocity of 5 meters per second from an initial height of 2 meters, I give you the height function. Find the maximum height of the ball. Later on, I won't even give you the height function. You'll just develop it from gravity. But for now, I'm giving it to you. Maximum height. Go to basic calculus. How do you find the maximum of a function? Yeah, where its derivative goes for a max. What kind of sign change do you want? Positive. You want to know where the height derivative goes positive to negative. What is height, which is position, derivative? What's the derivative of position? Velocity positive to negative. Does that make sense that that would be a max height when the velocity goes positive to negative? What's happening if the velocity is positive in terms of vertical movement? It's moving up, okay? And afterwards, when velocity is negative, it's moving down. So if I found a place where it stopped moving up and start moving down, isn't that the max height? Yeah? So it's logical. So what is velocity then? Function. Negative 9.8t plus 5. Now I want to know when the velocity is 0 because that's the great dividing line between its stops positive and negative. So that would be at time 5 over 9.8. And before that, say you looked at a small number it seems like if t was a small number like 0, then the velocity would be positive. And if t was a big number, then the negative would be bigger. It's negative. So it seems like it is a max height. I've got that going on. So now, did I answer the question? The max height is t equals 5 over 9.8. Answer the question. Make sure you answer the question. Is the question, when is the max height? It's what is the max height. So how do you find what the max height is? Yeah. You need height at 5 over 9.8. So you'd plug that into your calculator and you can find that. So you understand the idea? You bet. Okay. Given the position of a runner in the table. So this is pretty common that in real life you don't always have an equation. Sometimes you have data. So if I had a stopwatch and if the guy was running along the football field and I could see where he was at or she was at certain points, then I could estimate her velocity at a time by taking really quick measurements of time and seeing where she's at. But it is an estimate, and I would, in an AP problem, this is a very common AP part A, I would underline estimate big time, because if you fail to grasp that, and you make a little notation error, it'll cost you, all right? So, velocity is change in position at over change in time, right? Now, we know that in calculus, that's at an instant, that's dx dt. At a tiny microsecond, those 2 points are so close together that it's like the space between my hands. It's almost, there's space there, but it can't even be measured. It's so close. Well, all I have is points that are close to each other, but they're not this close. So I'm going to approximate it with change in position over change in time. Now you could actually do this, could be done 3 ways. You could say V of 3 is approximately equal to the average change in position from time 4 to time 3. The position of that young lady changed 8 meters in that 1 second of time. And so a good estimate would be that she's traveling 8 meters per second at time. You follow? This and this, they're required for the AP full credit. You must show where it comes from, and you must show that it's an approximation. Make sure that you're intentional, that this is an estimate, and it's showing where you come from. Do not make the foolish mistake of just starting throwing the table numbers at them. You'll get the right answer, but you won't get credit because you're not communicating where they came from. If you're going to skip a step, this one is the one that can be skipped. You can do that mentally. The calculation is fine, but that's got to be there. I told you could do this 3 ways. What's another way? Yeah, 2 to 3 is just as good. I mean, isn't that satisfy the idea of a limit being as close as you can together? So you could also say V at 3 is close to change in position from 2 to 3 over the time frame of 1 second. And that's more like 7 meters per second. Now, because there is a symmetric difference on either side of 3, you could also use the symmetric definition. And say something like x at 4 minus x at 2 in a symmetric way. That's exactly 1 unit on either side and as close as I can get. Keep in mind the bottom is going to be not 1 unit now, but 2. And so that is more like 15 halves meters per second. All those would be acceptable. Any questions? Okay, let's do this in an integration-y kind of style then. This might be new. All right, so using integration and an initial condition to find velocity or position by finding the plus c. Really, there are two cases here. You have to find the whole equation, or you just make a calculation. And I have examples for both. So say acceleration is given, and they tell you velocity at a point. How can you find the velocity at any point? Well, so find the velocity. What is the velocity's relationship to acceleration? Yeah. It's the integral, yeah. Isn't acceleration, actually, let's go, isn't acceleration v prime, right? So if I wanted v, then I need to undo derivative, so I need to anti-differentiate. So I'm going to anti-differentiate with respect to time. Please, don't be one of those knuckleheads that's not writing the differential. That's starting to tick me off. And on the AP test, they might not take off, but every college professor would, and I certainly will. So please make sure you write that. So what is the antiderivative of 7e to the t? 7e to the t plus c. Okay. So you integrate. And then you use the initial condition to find the c. Now I know that the velocity at time 0 is 3. So I can plug in for the velocity is 3, and for time is 0, and I have subbed in for 2 of the variables, leaving me with just 1, and c is what? 3 minus 7, or negative 4. So the velocity is 7e to the t minus 4. Please don't give me any nonsense like the constant is the initial velocity. That is not always true. No, that is sometimes true, definitely not always true. You can see the initial velocity is not negative 4 here. Okay, say we bumped up the integration a little bit in difficulty. If the velocity is given as this ugly function, and you want to find position, how would you do that? Oh, sorry, this should be position. There's a typo. I know position, velocity is the derivative of position, right? So if I want position, then I need to integrate. So x is the antiderivative of velocity. Now then, this will require some u sub e skill. If you take the antiderivative of root sine plus cosine, or times cosine, sorry, then you have a function within a function and a product. So what shall you make u? Sine of t. What's du? Cosine of t dt. So as far as substitution, everything goes easy. X is now the antiderivative of root u du, yeah? What's the antiderivative of u to the half? 2/3 u to the 3 halves. Okay. Okay. Now, do I need to sub back? Yes, okay, on a definite integral, you don't have to sub back because you change the limits for u, but in an indefinite integral, or an antiderivative problem, you do sub back. So x is 2/3 sine of x to the 3 halves plus c. How do I find the plus c? Use the initial condition. If I plug in the initial condition, then where does the 3 go? In for what? X, 3 equals 2/3 sine of 0 to the 3 halves plus c. What is sine of 0? It is 0, yes? So x is 2/3 sine of x to the sine of t to the 3 halves plus 3. All right, and then sometimes you have to go acceleration or integration twice. Try that next one on your own. Let's see how that goes. Also, would you please, you're going to get two constants of integration because you're going to integrate twice. Would you use, rather than just C, use C1, then C2? I don't know if that's how you taught, but that's how I like it done. It's dangerous to communicate or attach the same variable to two different quantities. That's just bad math. So I prefer you call them something different. You can use C and K if you like, but I don't like them both called C. Get -9 for your C1, and something like t squared plus 3t minus 9 for your velocity? The answer is yes, then keep going. If it's not, stop there and fix your velocity. This ain't gonna be pretty. Second one got a little ugly. What do you say for position there? Did you get 1/3 t cubed plus 3/2 t squared minus 9t plus 10/3? Yes? Okay. All right, let me know if you have questions there. If you didn't get that, then figure out why is it a conceptual or a arithmetic. All right. Last but not least then, using your calculator in a really different fashion. Now, calculator sort of does that problem, but it can't find the velocity and acceleration at any given time because it can't integrate. All it can do is make calculations of definite intervals. So you use your calculator in a little different fashion here, and this is what I would, there's a lot of meaning here. I hope you're following along because this should help you on a very common AP style question. All right, so fundamental theorem of calculus. There are a lot of levels, as I said to FTC, and this is another one. At an initial condition to find velocity or position at a specific, not general time. So say you have this function. Look at that function. 7e to the sine of 4 minus t arctangent. It's pretty gross, yeah? It's hideous for a reason. Do not try to differentiate or integrate by hand. You will be wasting your time. Not everything can be integrated. Not everything has an antiderivative. I can make an infinite number of functions that nobody could find the antiderivative. Not everything can be integrated. So keep in mind then that you're going to go at this a little different angle. You can't find the antiderivative. You're going to ask the calculator to make a ton of little rectangle area calculations instead of actually integrating. So here's what I'm getting at. Use the fundamental theorem of calculus, which is basically the idea of what happens when you do a definite integral, an area under a curve, to explain what this is equivalent to in velocity terms, and then the meaning of this integral. Well, the fundamental theorem of calculus says you do two things. So you have a definite integral, you integrate, and you evaluate it up or minus slope, right? When you integrate acceleration, what is it? Or you anti-differentiate. What's the antiderivative of acceleration? Velocity. So this is equivalent to v at 5 minus v at 0. Isn't that the fundamental theorem of calculus? Yeah? Now when I say give a sentence to explain the meaning of the integral, this is really hard to interpret. You're thinking of area under a curve and acceleration for a tiny microsecond times a little amount of change. That's like change in velocity over a little time frame. It will give you a change in velocity for 1 microsecond. And then you do it again and again and add in infinitely many times. Now, after all that's said and done, that's kind of abstract and weird. But this, really easy to understand. If this is equivalent, then just tell me what that is. It's a change in velocity. That's all that is. And when you integrate acceleration, you're finding change in velocity over a time frame. So the integral represents change in velocity. And you always refer to the limits of integration from time 0 to time 5. And I'll have units in the examples tomorrow. Tomorrow we'll do an AP day on this idea because it's huge. Okay, so how can I rearrange this expression to find velocity at time 5? And I should have said equation, not expression, because this isn't, it's two expressions set equal, so that's an equation. If I wanted v at 5, isn't that here? Yeah? Isolate. How would you find v at 5? Well, I would want to get this by itself, so I would move that over. Now that is just something I can move over. It's an algebraic term, so move it over. V at 0 plus 0 to 5 acceleration. Now would you just for the, again, shooting for the moon, let's talk what the cockadoodie this means. It's a whole bunch of symbol pushing right now. It has meaning. What is it? Any velocity can be found by, what's this? Starting velocity plus, and what did we just say this is? Change in velocity. Any velocity is starting velocity plus change in velocity. It all makes sense. No, I don't want it to be just symbol pushing. I want you to actually understand what each of those quantities represents and means. All right, now, you are not going to integrate that by hand. You're going to use your calculator. So I tried to get in a little in the problem set yesterday, but it was pretty clear that, at least in the last class, they were not obvious, they weren't totally clear on how to do a definite integral in your calculator. So if you have not seen this before, or you're not sure, please get out your calculator. We are going to put this in our calculator. The initial is 1. Okay, put it in first. 1 plus. Now to do a definite integral, there are lots of ways. I could go to menu and do calculus and numerical integral. That's a little more keystrokes than if you just do a shortcut of shift plus. You'll get a definite integral, shift plus. And from 0 to, I think it was 5, yes? Okay, put the limits of integration in. Now if I had done if this had been a multiple part problem, then I would probably put the function in the graphing menu so I could just call up F1. This is the only part, so I just type in the function. Type in the function, and the function is pretty hideous. 7e to the sine of 4 minus t. 7e to the sine of 4 minus, I'm just going to use x because in the 84, which is what I learned on, that's what you had to do. Oh, by the way, do you have the syntax? Did you get the syntax yesterday? Okay, cool. And then it was arctangent, I think, which is in the trig menu in the second row, which I don't go to very often. And I think it was t over 12 or x over 12, depending on what variable you're using. Is that correct? All right. And if we all agree, that would be super. I'm getting 11.423, but I'm actually not sure if my calculator is a radius, quite frankly. We're good? Oh, good point. Yeah. Smart. Yes, you're smart. You're smart. 11.4230. Yes? So in terms of what I would expect, this actually is fine for me when you're doing a calculator problem. I don't expect you to rewrite the function. That's a time waster on the AP exam. If the function's been defined, just call it by its name. And 11.5423, excuse me, 11.423. Now I will say this, if you don't give this, then they won't even look at that. You can have the right answer all day long, but you'll get 0. Nothing, if you have no work to support it. Okay? Okay, so this is fairly similar. Try this one on your own. It's like it, but not exactly like it, and it'll give you good practice. It is also calculator active, so please do. Hi, Zoe. On the last example I did. got parentheses in that, baby. Be careful. Uh-oh. Oh no, it's 2 plus, that's right. Did you get 4.4608? Okay, let's go over what the heck as well. If you use the fundamental theorem to express the equivalent form of that, what is it the same as? Antiderivative at upper minus lower. What is the antiderivative of velocity? Position. Whether you called it P, or no, they called it X right there, so you should be using X. It's X at 4 minus X at 0. So you're making tons of little rate times time calculations to find the change in position from time 0 to time 4. You could also say change in position is physics work. Darn it. It's displacement. Yes, change in position is displacement. Okay. How could you arrange this expression to find initial position? Now, this one's a little different because you're looking for starting position, not ending position. So it's not going to be just the same as the previous one. If I isolate that, then it's going to involve either moving that and divided by a negative, or I actually think of this moving this and moving this back. Either way, it's X at 4 minus the integral, which in plain old English means starting position could be found by ending position and subtracting away the change. I'm removing the change that happened, undoing the change in position to get back to where it was before the change in position happened. So then, if you do that well in your calculator, you should get 4.408. We'll practice this a lot tomorrow, do an AP problem or two, and that will be good. You have the use of sheet still, yes? Let me know if you have questions on the use of sheet. Use of. How do you think about a quick 1 or 2 question use of quiz this week to see if you are doing the homework well and if you are having a clue? What do you think?
Do we have a choice?
What?
Do we have a choice?
Yeah. No, you don't have a choice. I just want to know how you think. Which one? 1 and 3, yep. 1 and 3. 1 and 3 are ones I should have done examples of. Those are some of the hardest ones, and I just blew it. So I will be happy to. And then 11 is fairly similar to it if we want to go over that too. So use of number 1. First of all, what makes this hard problem is you cannot distribute. If I had a problem like this, that wouldn't require use of because I could just distribute it and do turn by turn, right? Mm-hmm. When you have a power or something else going on, then that's not there, and everything gets more complicated. So that's the idea of use of here. If you let u equal x plus 1, what I wish I would have told you is that when you go to sub, every one of these things needs to be subbed. Every one. And so if I make this substitution right away, that's been done. Cool. And dx, I can do that pretty well too. If I take my derivative of my du, then that's dx. And so dx is totally equivalent to du, so that's not an option, or that's not a problem. But this, that's a problem. I need to put something u-ish. I need to sub in for that. So there are two schools of thought. One is to say, well, what is x equal to? Wouldn't you say that x is u minus 1? And therefore x plus 2 would be u minus 1 plus 2, or x plus 2 is equivalent to u plus 1, yeah? Another person in the last class said, do I have to do all that, or can I just say x plus 2 would just be 1 more than this, so u plus 1, and that's fine. That makes sense. To get, if I want to know what x plus 2 is, you can just add 1 to both sides and get there just like that. When you substitute that in, though, make sure it's in parentheses. And now it is starting to be a problem like that. I can distribute. And I get u to the 5/4 plus u to the 1/4. Some you can integrate term by term, no problem. So if you raise it by 1, it becomes 9/4. Divide by the new is 4/9. 5/4 divided by the new is 4/5. And then remember, there's two types of u sub, when you do have to sub back and when you don't have to sub. On an indefinite integral, you do sub back and put it back into x terms. So I'm going to put in u's place back with x plus 1 every time u came over. On a definite integral, you don't have to sub back if you change the words. Okay, so that one's ugly because you had this extra term you had to kind of account for and make. 3 then is a little similar but not identical. So you have this. They tell you to let u equal x plus 1. So that gets me that far, yeah? I've got this one accounted for. Du is dx, so that's nice. That didn't have any tweaking, so I could replace that. That's been accounted for. But in this case, that extra term I have to account for is x squared. Well, to sub for x squared, let's start by finding x. If u is x plus 1, then x is u minus 1, okay? And therefore x squared is u minus 1 squared. It'd be a shame to blow this by bad algebra. That's definitely not u squared minus 1. It's a FOIL-y kind of thing. U squared minus 2u plus 1. So, in place of that, I'm going to have to put, I don't have enough room. I'm going to need a little room to squeeze that in there. So, u squared minus 2u plus 1. All right, now what? What to do, what to do. Can you integrate it the way it is, or how do I clean that up? Yeah, multiply it out. So this would be u to the 5 halves, minus 2u to the 3 halves, plus u to the 1 half. Now we're ready. Raise each power by 1, u to the 7 halves, and a 2/7 out front. 2 I'm just going to leave there, u to the 5 halves, and a 2/5 out front. And u to the 3 halves, and a 2/3 out front, and a plus c at the end, and then u sub back. So then at the end you should have a really long expression with sums to powers. Okay, good questions. Those are right. Other questions on the u sub? Okay, cool. If you are not good at those u subs, you should come in and go over them and get some extra practice because they are critical that you can do that. What's the next oldest thing you have? 52?
Yeah.
Or 51? 52? I think it's 52, yes?
Yeah.
Okay. Do you have questions on 52? Yes, ma'am.
Oh, how many planes?
24. 52, 24. I don't know if I made a key for this. But before the sub, thing was kind of a crazy time for me. I did not necessarily get everything done I need to. I have a 51 key, but I don't see a 52 key. So I'll have to put that on. Is it placed or is it straight? I'll put the key on line to 52 and I'll have it tomorrow, and I'll take it tomorrow. But for now, let's look at the book problem. Doo-doo, doo-doo. Oh, shucks. Bless you.
Happy Halloween. Please rise for the Pledge of Allegiance.
Oh, yeah. I can write that up.
Ready? Begin. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Yes.
All students today for 7th hour 9th graders with last names CO to GRA will report to counseling. 9th graders with last names O through SO will report to E100.
8th graders with last names HO through PRI report to the auditorium today during 7th hour for a meeting with Sister Northwood.
Your students need your tutors need to remember to keep your teacher in the loop by filling out the learning objectives sheet on a weekly basis. If the teacher requires you on a day that you have peer tutoring, you would need to advocate for yourself and offer to come in before school, after school, or during 7th hour the following day. If it can't be rescheduled, be sure to contact your tutor and let them know.
Ricky Halloween this year in both CSU Pueblo and the University of Wyoming will be in counseling today during 7th hour. Delaware is proud to have 3 faculty members, Miss Henrico, Miss Aaron, and Miss Ashley at one of the great colleges.
Tomorrow, look forward to Seattle University, who way back in 1933 offered high school for women, which was highly controversial.
This is really a question. What function does it work where the product of 2 is the same as the sum of 2?
The cost is $5 for the
So,
planetarium,
does that hold
leaving
true?
at noon and returning at 5 p.m.
Log?
Hurry to get permission for the
That's true for logs, but no other
First
function. For
career
example,
exploration lunches tomorrow during both lunches in the library commons. The topic is nursing, the most trusted profession, and our guest speaker is Mr. Jason Simpson. If you're interested in a medical career profession, this is a must for you. All junior and senior high students are encouraged to attend. No need to sign up, just show up.
Senior Denver Fall 2017 Preview Day for juniors and seniors is Friday, November 10th from 8 to 4 p.m.
that's the thought process.
If you would like to help a child experience the pleasure of opening a gift for Christmas, please donate to Operation Christmas Child. There will be a table outside the cafeteria that pledges all of them.
Oh,
We can
yeah.
all gifts that will fit in a shoebox. We also need cash donations to help with the income.
It's
Thank you very much.
real. It's like.
Senior high students, seniors, if you have any transcripts that you would like submitted for a November 1st deadline, request that in Knoxville. Please, it will not be done automatically. Questions, come to counseling.
Seniors and your parents, do you need help in completing the FAFSA pre-application for federal student aid? Red Rock Community College, Lakewood, Kansas is offering assistance